I'm a teacher Olimboka Nsajuga Masame. Welcome to Olimboka Physics. We have a question from SERWAY&JEWETT, question 66, chapter 35. Reflection and refractions at a plane surface. A transparent cylinder of radius r, that is 2.0 meter, has a mirrored far surface on its right half as shown. Its right half as shown, mirrored surface. A light ray traveling in air is incident on the left side of the cylinder. Incident at the left side on the cylinder. The incident ray and exiting light ray are parallel, and d is equal to 2.00 meter. Incident and the exiting rays are parallel, as you can see, and their separation distance is 2.00 meter. Determine the index of refractions of the material. This is under the sections of refractions and reflections of that take place in or on the surface of the spherical object, transparent object. Let us use this concept to explain the rainbow formations, because we assume that the spherical shape, the water droplet that found on the atmosphere or skies, is the one that is responsible to form a rainbow. This series of water droplets on the skies, when light enters through it and gets refracted on the surface and undergoes total internal reflections inside at the other sides, at the edge, then it leaves the drops and emerge out, and the process causes what is called dispersions of colors of white light. Let us see how this takes place by considering the rainbow formations by using the diagram below. We have an observer here, and this is mountains. So this is mountains, and this is horizon. This dotted line representing the horizons, and we assume below the mountains there is a valley. There is a valley downward here. This valley has got a river, and because we have a valley and we have a river, then we can see this is the conditions for the formations of rainbow. The first conditions, we must have a mountains or highlands, the highlands place, and we must have the lowland place where we have a observer to be at a lowland place. But the observer must face towards the highland place, such as mountains place, and he must be at a position that the sun rays, or the position of the sun, is behind his positions, and this position is called the anti-solar positions. It is found at a lowland. The observer is anti-solar position. It's a position whereby the sun is behind the visions of the observer. The observer is visualizing the highlands and observing the rainbow. How these rainbows appear to this observer? The rainbow appears as a result of the rays from parallel from the suns, that is striking above the horizon on the surface of one of assumed spherical water droplets on the sky that undergo dispersions. After undergoing dispersion, as it enters through water droplet, the red color is dispersed, is the least, diverted is the least, while the violet color diverted is the most. After striking the edge of the water droplet, the boundary between the water droplet and the air, we know that when the condition is sufficiently, the total internal reflection is achieved as critical angle the incidence angle become greater than a critical angle. Then there is a first refractions, one total internal reflections, and the second refractions, where we have emergent rays. This emergent rays is counted as of dispersed colors of white light. The violet one is on the top, while the red one is on the bottom. The red rays is out of the range of the visions of this observer. Therefore, the observer will see the violet color as it is inside the rainbow, and it is somehow bold and clear, distinct, or it is boldly visualized by the eyes of the observer, while the red is somehow faint and it is above the arc of this rainbow. Okay, and as the rest of the color is followed as the arrangement in the dispersion of the white color, as that you have learned from the dispersion of the white color inside the triangular prism. Okay, this is a kind of rainbow is known as primary rainbow, as there is a one to two internal reflections that take place inside the water droplet, the spherical water droplet, and this violet is it is just deviated with 40 degrees from the incident rays, and this red is deviated 42 degrees from the incident ray. We can see in the next videos how we can achieve to get this deviations angle. And now this kind of rainbow is rainbows that formed at low length, the rainbows that have a short arc and shorter rainbow and formed at a somehow lower at the surface of the mountains or highlands, while this rainbow has got the condition as I have right here, that this sunlight is above the horizon, and this observer eyes is at the anti-solar positions, as all rainbows must be under these conditions. And the rainbow formed somehow at highlands, but it's shorter and low rainbow arc. And when we have another rainbow that formed due to sound rays that appear to cross the horizon, that when the sun is at below the horizon, and the rainbow formed, the rainbow will be formed at the higher place above the highlands, especially on the clouds of the skies, and the rainbow will appear longer and not such intense rainbow. That's like a dull rainbow, and the condition is vice versa to this one. Okay, let us now consider how we can understand the concept of the deviations, angles of deviations, and we can understand how to calculate the diffractive index for this cylinder transparent object. Okay, this is our assumed cylinder transparent object or spherical water droplet. Now this is the center of the droplet, and this is edge where total internal reflection takes place, and here we have one total internal reflections, and therefore this is primary rainbow. And when we put this is center, and now this is the radius also, and this also is radius. We know this is radius, this is radius 2, and the distance from edge to the edge, this is diameter. And now because we have